Identify A, B, C, D respectively in the graph below. This graph is not in our books. This is a graph that we can mark based upon the observation we make in a dual beam cathode ray oscilloscope. See, during a active transportation of impulse across an axon, you can insert the two electrodes of an oscillon. Remember, it is an excitatory electrical current that is passing along the membrane of an axon. That is what's called impulse. Impulse is just an electrical pulse. This is flowing through the membrane. So, you insert an electrode to the inside and another one to the outside. And what is the electrical potential that is developing there during this process? You can measure not by a voltmeter, because voltmeter will be used for measuring large quantity of electrical disturbances. Here it is only very slight, and it is in millivolt. 1 by 1000 of a volt is 1 millivolt. This can be measured only by a dual beam cathode ray oscilloscope. Okay, so we are all giving to the amplifier, and from the amplifier it is given to the cathode ray electrode. So what will be the nature obtained? We will be having the values recorded and the changes recorded in this way. We know that when a axon is not conducting any impulse, membrane is at rest, there is a potential developing. That's called resting potential. During that resting potential, the value may be varying from -40 to -90. We take the average of that. That's why we say that resting potential is -70. Why we say it is -70? Why we say that it is -70? Inside is negative. That's why we take the value negative. Negative means inside is negatively charged. Okay. This is the average value. Okay. So resting 70. This is the 0. And from here you will be having plus values. This is the minus values. This is the neutral. Okay. And we have to apply a potential or a stimulus which is sufficiently strong enough to activate a neuron. That minimum strength required for activating a neuron is called threshold value. So it should be minimum 10 to 15 millivolt higher than that of the resting potential. Resting potential is -70. So this should be at least 10 to 15 means 10, -10 higher. That means it should be -60 or -55. So minimum -60 we have to give. That -60 is the threshold. Okay. So we are having, this is the resting potential. So resting potential is 70 and this is -55 to 60. Then only a neuron become active. And because of the influx of sodium, inner side is becoming positive and it goes past that 0 and then goes to plus 30 millivolt. That plus 30 is the action potential. So resting potential is -70 millivolt, plus 30 is the action potential. Then again it come back because the sodium ion channels are immediately closed and potassium is again moving out, and because of that there will be again coming back. That is coming back to polarized condition is called repolarization. So B represents depolarization and C represents repolarization. And during repolarization, remember, the entire process will be completed in a very small time period of 0.5, in a small period of 5 millisecond. 5 millisecond. Okay, it is so quick. And for a fraction of a millisecond, 0.5 millisecond, that is 0.5 millisecond, the potassium ion channels are more widely open. That means more potassium is going out. As more potassium is going out, the inner side is becoming more negative. The value goes even past -70 and it may reach even -80. Now, immediately the potassium ion channel regain their original permeability, and now it is coming back to -70. These are all measurable using double beam, dual beam, oscilloscope. Okay. This is the graphical representation of all the activities that are all going on in an axon. Okay. This is not in our books. So, A, we are having the threshold stimulus applied. Okay. This threshold stimulus will be minimum -55 to -60 millivolt. Now, B is depolarization, C is repolarization, and D is hyperpolarization. It is called hyperpolarization. Why? Because inner side is becoming more negative. So the option goes to apple.